All right, so I'm just going to make a video kind of going over some of the graphing areas that hopefully I can reinforce if you're having some problems. Again, hopefully if you're watching this video, you've attempted those activities that were the kind of lesson and homework. If still some of the stuff isn't making sense, then hopefully this video will make or give you some clarity. So again, remember when I'm graphing our trig functions now, by now, I hope like when you look at this graph that you see right here, like you know that this one is a graph of sine of x, right? And just a reminder, right, when I look at this, like when we graph trig functions, we are always going to be graphing the key points. So what are the key points? Well, there's 5. There's my intercepts, 1, 2, 3 for sine. And then I have my max and my min, okay? So again, when I'm looking at this and we know like where are my key points, I know the period of sine of x is 360, right? And then if you notice, right, like from when we used to spin like the terminal arm, like, and I would divide this into quadrants. How many quadrants do we have in one rotation, right? We have 4 quadrants, right? So it would make sense that like my graph is divided into 4 equal chunks. So like if I divide 360 by 4, I get 90. So this actually gives the scale for where my key points are going to be. Where are my key points going to be? Every 90, right? So 0 plus 90, max. And then another 90 takes me to 180. I'm at my x-axis. Another 90 at 270. I'm at the lowest point. And then another 90, I'm at 360. So this will help us when we actually have to graph ones where the period is no longer 360. All right. Again, the amplitude, that's this, remember the distance from the axis of the curve to the max and the min, right? So this, my amplitude is 1, here the amplitude is 1. And then this line here, the x-axis is what we call the axis of the curve. So just like remember for parabolas, I had a, sorry if I go down here for a moment, for parabolas, I apologize for this gross parabola, but like, I had this line, which was the axis of symmetry. Okay. And because a quadratic pattern is a symmetrical pattern, like it made sense in that if I have a line that goes through the max or the min, it's going to be perfectly symmetrical. Now, periodic functions aren't symmetrical, but again, like this is like a horizontal line that slices the periodic function in half from its max to its min. Okay. So now, same reminder with cosine, right? When I look at cosine, the key points are every 90, right? So at 0, I'm at 1, and then at 90, I'm at 0, 180, -1, 270, 0, 360, and 1, right? And then when I draw my nice little wave, right? Again, it doesn't have to be perfect. And then remember, like this is the amplitude. A is 1. This is the amplitude. A is 1. Okay? Same deal, period is 360 because I haven't transformed it. Now, when I graph transformations, I kind of mentioned that we're going to be talking about the same things we talked about in the first unit. So all these things here, right? Like the A values of vertical stretch or compression. Okay. We're not going to really use this terminology anymore because I know it's the amplitude, right? And then the K value. Now I apologize. This is an older note. I may have like these letters, like the K and the D and the C, I may have switched around. So don't get too worried or stressed about the alphabet. But like if K is the horizontal stretch of compression, that's not going to help me anymore. But K gives me the period. Okay. The phase shift, which is left or right, will help determine the starting position of the graph. And then the vertical shift, obviously up or down, that determines the axis of the curve. Okay. So when we graph, if we understand like all this terminology, then it'll make graphing trig functions relatively easy. I would argue, if I had anyone to argue with, that graphing trig functions, if you really understand what these words mean, is easier than graphing like a rational, right? Remember this one? If I bring back nightmares, remember that one here where it was like this and then like that? I know. It's terrifying. Okay. So let's just do a quick example where we're just going to talk about transformations. So say I have something like f of x equals -2 sine 2x minus 30 plus 1. Okay. So again, if we want to describe the transformations, okay. Well, here, so like my A value is -2. Okay, so we know it's a vertical stretch. Like it's a vertical stretch by 2. It's also reflected over the x-axis. Okay. But in the land of trigonometry, right? Not that we're going to ignore this, but what are we going to say? Well, we're going to say like the amplitude is 2. Now notice the amplitude is not negative because the amplitude is the distance from, or half the distance from the max to the min. Okay. So that's all right. Now I'm going to try to be consistent. I think I called like this number. I think I called it D in the previous notes. So I'm just going to do that for now. So D is 2. Okay, so now remember what was that? Well, this was a horizontal compression by 2. Okay, so what that means is that if I just, indulge you for a moment, right? If I had a graph that looked like this, now I'm going to squeeze it so that it's going to look something like this. Okay, so if you haven't realized this already, right, this will obviously affect the period, right? Because if you think about it, right, if I have y equals sine of x, right, what's the period of sine with no transformations or anything? It's 360, right? Now, if I have something like this, sine of 2x, okay, that means if you remember what I do is I divide the x values by 2. Okay. But now for me, if I want to find the period of this function, what's the period of the graph sine 2x? Well, the period is going to be 360 divided by whatever the d value is. Okay? So it's going to be 360 divided by 2, which means that the period of this one is 180. So this is super important. Okay? Like notice I didn't care, like this horizontal, like this stuff up here, like I don't really care about the terminology we used before. Now I'm saying, hey, if this is, if the d value is 2, then I'm squishing this graph horizontally, which means that the period now is going to be shorter. Okay, it's not going to take 360, it's going to take 180. Okay? And then if I go back, let me see. So I have now this thing, sorry, this I called H, and then this I think we called K, because I wanted it to be consistent with the quadratics, right? Right. So my H value, which is negative 30, right? So remember, it's negative, so that means I'm going to move in the opposite direction. So 30 degrees in the positive direction, right? And then my K value is 1. I think it's 1, right? Let me double check. Yeah. So again, that's my vertical shift. So that just means I go up 1. But this is also this is my axis of the curve. All right. Because if you think about it, where is the original sine graph? Let me go back here. Okay. Here's my original sine. I'll erase all this stuff so that it's not as busy. Okay. Right. So again, this is y equals sine of x. Okay. Where is the axis of the curve? The axis of the curve is right here. Okay, the line y equals 0. Now, if I perform transformations on this, and then if I add, like say I go plus 2, then what happens to this line? This line goes up 2. So that would be all the way up here. Right? And then so would these points move. Right? So then this point would be up here. This point would be up here. This point would be here. This point would be here. So I'd have a graph that would look like this. It could go up and then down and so on. Okay. So now what's my y? This is y equals 2. So that's why that vertical shift is always going to give me that line, which is going to be key for graphing a nasty looking function. Okay. So I hope that kind of makes sense. So again, we described the transformations, right? We did left, right, up, down, all that kind of stuff. Okay. So now when we sketch, there's certain steps that we want to do to make sure we sketch things properly. Okay, so first what we'll do is we'll draw the axis of the curve. Then we will draw the line for the amplitude. We'll put in the period and the scale, and then we will draw the curve. Okay. So here I have kind of some hints or some little comments, right? If I go from here up to here, right? The line that cuts the graph in half, that's the axis of the curve. Imagine it's like the horizontal axis of symmetry. That's what I told you before, right? Draw the line for the amplitude, right? For example, sine of x. If this is the axis of the curve, I know the amplitude is 1. So 1 up, that's the max. 1 down, that's the min. All right. For the period in the scale, we usually will look at the horizontal translation to determine what the scale should be. Okay, so this will make the shifting really, really easy. Or hopefully, okay? So let's graph this together, okay? So notice I don't have graph here because I am a powerful mathematical human. I don't need it. Now, I apologize. I do get this nice, cool little thing that I can draw like perfectly straight lines. But I mean, so can you if you have like a tablet. I'm assuming most of us have some sort of device. So again, let me just draw that a little bit nicer. Okay. And then I'll put a little grid. I mean, I'm gonna have to put a scale on here, right? So let's just, okay. And I'll try to be as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's cool. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I'll just put some here just for fun. Okay. So so I'm not going to put any numbers on here yet. So now what we're going to do is we're going to say, okay, so what is my first step when I graph? Well, I said back here that let's draw the axis of the curve. Okay, so again, when I look at my equation, the axis of the curve is this number here, right? This is the axis of the curve. Okay. So now if we establish, I guess we might as well do that right now. This will be 1, 2, 3, and so on, -1, -2, -3, right? So that means my axis of the curve is going to be at y is +1. So that's right here. Okay. So let me just, maybe I can change that color for fun. How do I change the color? Why? Properties? Ooh, there we go. Okay, there we go. Yellow, done. Okay. So this is my axis of the curve. The line y equals 1. All right. Now, right, so we've done this. What's my next step? Draw the line for the amplitude. All right, that seems pretty easy. So again, when I look at my equation, I say, well, like, that is my A value. So, and the amplitude is 2. Okay, so that means 2 up from the axis of the curve is going to be the max. So let's just add that. So 1 plus 2, so that's going to be at 3. Okay. And then 2 down, so that's going to be at -1. Okay. So again, let's just color that something else. Let's go blue. All right. So again, here, my max is at y equals 3. My min is at y equals -1. And again, what's the distance from here to here is 2. The distance from here to here is 2. All right. Everybody cool with that? Now notice we haven't even began talking about the scale for the y-axis yet. So that will be my next step. So if I go, let's see. So let's just say, okay, we've done this one. Okay, see you later. Okay, so now next, put in the period and the scale. All right, cool. I think we can handle that. So again, when we look at my graph, we say, okay, what is the period? Okay, say we don't know, but remember, like, how do I figure that out? Well, remember, like, this number here, right? If the D value is 3, that's a horizontal compression by 3. All right, but in terms of trigonometry, what do I know? Well, I know if I go 360 and divide it by 3, that will give me the period. So that is 120 degrees. Okay. So this is why, notice we don't draw the base function, because when we deal with trig functions, their domain, right, for one period is 360. That's pretty long. Like you've never drawn a parabola where you include all the coordinates on the x-axis from like 0 to 360 or 0 to negative 360. So this is key. So now I have this number here, which is going to be super important, right? So I have the period is 120. Now, again, remember when I draw, when we drew the regular sine of x, right, there were always 5 key points, right? So now if you remember, for like when the period was 360, how do we determine like where the key points went? Well, they were every 90 degrees, right? Because I divided 360 into 4 equal chunks. So now I'm going to do the same thing. Okay, just not with a period of 360, but with a period of 120, right? So 120 degrees divided into 4 equal chunks is 30 degrees. So this here, I'm super stoked about, because this is going to give me the scale that I'm going to go up by on the x-axis. Okay, so scale on the x-axis. Okay, so that means every tick mark I have here, right? So 30, 60, 90, 120. That's nice, isn't it? Right? Now I could keep going because I just keep adding 30. So 150, 180, 210, 240, but we're just going to graph one cycle, okay? So check it out. So now what I'm going to do is now I'm going to graph, but now my key points aren't like 0, 90, 270, or sorry, they're not 0, 90, 180, 270, 360. My key points now are, right, because sine starts at the axis of the curve, and then 30, I'm at a max, and then at 60, I'm at the axis of the curve, 90, I'm at the min, and then 120, I'm at my full period length. So this is almost my final graph. Okay. So notice, if you can check, what's the, if I feel what is my amplitude, right? Well, we know my amplitude is 2, right? So it's going to go here. Is this distance 2 and this distance 2? Yeah. Axis of the curve is 1. Cool. Now there's 2 things that we forgot, or that we haven't done yet. So if you look, okay, here I have this phase shift, so I haven't shifted this yet. I gotta shift it 30 degrees, and that is super nice because if you look, every tick mark on the x-axis is actually 30. So I'm just moving it 1 unit across. Now, the one thing that you maybe already figured out is that this too is negative. So actually, this graph, when I draw it, it should be reflected. So I'm actually going to draw it like this, right? This point here This one's going to go down here. This one is back up here. So it's going to look like this. Because my A value is -2. So let me just delete that. Oh, I didn't. Will that delete? Sweet. This I'll just get rid of. This I'll just get rid of. That. Okay. Sorry, this one I kind of drew ugly. Oh, I know why, because it made that a straight line. Let me just. I'll fix that with 1 second. So yeah, that should be like that. Oops. Like that. There we go. Okay, that's, I guess, a bit better. All right. So my last move is just to shift it 30 degrees this way, which is going to be just like across 1 unit. So 60 goes to 90, 90 goes to 120, 120 goes to 150, and then I have my final graph. Okay. So again, notice, like, you know, and we can obviously check all this stuff out. You can say, okay, well, you know, again, this part here, I know my amplitude is 2. So the distance from the axis of the curve to the max, you know, should be 2. So I look, what's from 1 to 3 is 2. From 1 to -1 is 2, right? I have 1 here. That's my axis of the curve. That's cool. I know from this 3, the period is 120. And if you count what the gap from 30 to 150 is 120. And then I've shifted it correctly from the original graph. Okay? So hopefully that kind of made sense. Obviously, I can post some more videos if you feel the need to, in terms of graphing. And just a heads up to those of you who haven't finished the lessons in the homework on decimals, to do so, and then try to get as much of the homework done as possible, because next week this is the end of Trig. So we will be having an assignment that will deal with the second unit of Trig, which dealt with, if I remember correctly, we did Trig identities. We obviously graphed. We did properties of trig functions. Transformations, periodic behavior, and I believe that is all of the second unit. Okay? So I hope everyone is doing well. Again, if you need some help, reach out, send me an email. Hopefully everyone is not going crazy, and weather's going to get nicer soon. Hopefully our lives will become a little bit more normal. Nice to talk to you, and we'll see you later.